Hello everybody, I want to welcome you all to this webinar on lean manufacturing. My name is John Holtham. I'm hosting this webinar today for our Director of Sales, Alan Lessing. Click the screen now. We will spend about 40 minutes on the webinar, then come back to myself to open it up for any questions you may have. A couple of housekeeping items. On the GoToWebinar control panel, there is a download button where you can download a PDF copy of the presentation. Feel free to download it. There is also a question box where you can type any questions as we go through the presentation. They will come to our attention immediately. At the end of the webinar, if you are on a telephone or have a microphone, click on the little hand icon and I will unmute you to ask you questions. At the end, we will have some wrap-up information for you, so you can contact us directly to obtain more detailed information one-on-one. After the webinar, you will receive an email with a link to access a recording of this webinar, so you can review it again if you wish, or forward it to anyone else in your organization who may not have been able to attend today. Thank you. I will now hand over to Alan.
Well, good morning, good afternoon, as the case may be. Welcome to the webinar. We're going to focus today on lean manufacturing and how you can implement this in your organization. And we'll also be showing you how lean manufacturing can be enabled in our solution, OptiProERP, on the SAP Business One platform. That being said, hey, sit back and enjoy. Hopefully you see something that's edifying for you. So I guess off the top, the big question, what is lean? The concept has been around for a while, but I think a lot of people are still struggling in understanding how to move from kind of a traditional manufacturing environment into lean manufacturing. At the top, lean manufacturing focuses on a very core principle. It's called value. And value, by definition, is what your customer is prepared to pay for. Obviously, the customer is paying for a product and the functionality of that product. But what sits behind that is how we manufacture that product, how we deliver that product, and what are the processes by which we do it. Value is only what the customer is prepared to pay for it. So there's a bunch of things that happen in the manufacturing process in delivering a product. Understanding the difference between value and waste is very, very important. Waste is certainly something that a customer doesn't want to pay for it. And waste, by definition, are things like, queue time, setup times, production overruns, downtime, scrap, rework, all, terms that we were very familiar with and something that we deal with every day. But clearly something that we have to drive out of our manufacturing processes. In doing that, we should be focusing on continuous improvement. So an ongoing effort every day on every process, every activity that we do. We have to be scrutinizing it for efficiencies. There are no sacred cows. Many organizations have processes in place that are driven, by history, i.e., familiar phrases. Well, we do it this way because, that's the way we've always done it. Or we do it this way because that's the way the industry does it. Or we do it this way because our business solutions only support this. Well, you can hear in those statements, we say them, but the reality is, there are no sacred cows in continuous improvement. We're always looking to continuously improve and build efficiencies, more and more efficiencies into our business processes end to end. So why do we want to, do lean? Well, let's look at some things if you can recognize them in your organizations and see what kind of what part of the ledger you're falling into. traditionally, our manufacturing plans are driven by a sales forecast. Not necessarily lean. Production plan should, in fact, be driven by sales orders. Traditionally, we look at the manufacturing runs and we say, well, the more we produce, the less time we spend per unit, and therefore that makes it cheaper. Economies of scale. The reality is, in a lean manufacturing world, the ideal lot size is 1. If it's sold, we build it. End of story. And we build it from the back of the process as opposed to the front of the process. Traditionally, we look at projects as something that's driven from the top. An executive or C-level has an idea, and the organization mobilizes it and executes a project. So it's more top-down. From a lean manufacturing perspective, we have hundreds of continuous improvement projects on the go at any time, and initiatives are driven from the bottom up. So the hands-on executional people in the organization understand what they do day to day, and they're the ones that are proposing improvements in their processes. So they're small improvements and continuous improvements, and very quickly executed. In the beginning, it's low-hanging fruit. They're self-evident inefficiencies, but as time goes on, they become more sophisticated and more knowledgeable as people understand the power, of their experience and their knowledge, and they drive improvements. So, have a look at these comments and see where you are on these tables. How do we get, let's go the right way here. How do we get there? What are the other things that you're looking for? Well, again, what is lean, what's not lean? Well, traditionally, we push work orders, through the manufacturing process. And in a lean manufacturing, it's pull. The customer says, I want it delivered by Friday, and every business process mobilizes from that date and pulls through preceding operations to pull through that demand. People talk about inventory. What side are you on? Do you have lots of inventory sitting around just in case something happens? Well, the whole concept of just in case tells you that it's waste. In lean manufacturing, we're talking about, the value, and the only inventory that really has value is something that is sold and being pulled through to a delivery. Lean manufacturing thinking, if it ain't broke, leave it alone, right? Hey, everything's okay. Things are running smoothly. Everything's good. Customers are okay. Let's just let well enough alone. In a lean manufacturing thinking, again, continuous improvement. In another way, if it ain't broke, break it. We can always be better, and we should be better every day. Traditionally, we talk about quality control. So we're saying, well, we have processes. We know that we're making bad parts from time to time, but we put in quality control so we make sure that those quality defects don't go out the back door. You're talking about waste here. The fact that we've expended time to make bad parts, there's time gone, there's money gone, there's replacement gone, and there's discombobulation in your production schedules as you attempt to replace it. We should be talking about quality assurance. Quality assurance is, again, we're looking at our processes, we're improving our processes, and we're designing our processes to ensure that we don't make bad parts. This is quality assurance, and it's something that we really have to move to. Lean manufacturing, they have a traditional thinking toward vendors, right? How do we drive costs down? Well, we squeeze our vendors, we push our vendors. Yeah, okay, not really. in a lean manufacturing world, our vendors are actually part of our organization. Just as we review, internally, components and component designs to see how we can, make them better, cheaper, faster. We should be working with our vendors in the same way. Our vendors, understand how to make parts. They also understand where the time is spent in making those parts. Vendors are fantastic in coming up with new ways and new machining processes and new ways of machining things so that they can make things faster. They'll sit down and they'll tell you, I spend a lot of time achieving, this particular surface finish, or I spend a lot of time achieving this particular tolerance. Do you really need it? Traditionally we say, well, of course, let's tie down all the tolerances, like make them really, really tight, and we'll make a good quality product. Well, the reality is, the time spent to get 2/10 versus the time to get, 2 thou are vastly different. That difference is money, and that difference, quite frankly, costs your customer, and therefore it's an opportunity for us. Again, look at the different concepts. Where are you? Are you traditional or are you pushing lean? So, how do we do lean manufacturing? Well, there's a bunch of different concepts. We're going to talk about them now. A lot of these are supported by, relevant ERP systems. We're going to show you something in our solution, OptiPro, that'll allow you to achieve lean manufacturing and the flexibility that you're required to do lean manufacturing. Your tools are very, very important. You remember we talked earlier, why do I do it this way? Well, I do it this way because, my solutions, my ERP, force me to do it that way. Hey, come on, let's understand what ERP is for. ERP is to assist your business. It's not supposed to drive what you do. It's supposed to support what you do. We're going to show you something that can do that. So, lot size 1, we've talked about that before. If it isn't sold, don't make it. Really that simple. There's a lot of things you have to do, within your organization and your processes to get there, so that you can actually do this very, very effectively. But lot size 1 is a utopia, and you want to move your organization as much to that as you can. You don't want to be making 100 of this and 50 of that if really only 20 of it's sold or 5 of it's sold. So again, big opportunities here. Just in time. The concept of JIT has been around for a long time. And, again, this is very supportive of lean. It essentially, just in time says, well, let's deliver things, when we need it, in the quantity that we need it, at the place that we need it, just in time. Like, listen to the words, right? We're talking about lean manufacturing. We're driving out queue time. And getting things where they got to go exactly when we need them, right? If I don't need it, I shouldn't have it, right? Just in time. Kanban, the philosophy of Kanban, Japanese term, and a lot of what we're talking about here is, comes from Japan. They got something going over there. Kanban is, by definition, pull, right? So a Kanban pulls requirements from its preceding operation, and that preceding operation only makes it to that particular demand. You see what we're talking about here. Kanban is pull. SMED, single minute exchange of die, another Japanese concept. This speaks to specific manufacturing operations that require die changeovers, or tooling changeovers, or setups. And this is sitting down and understanding that if the machine, if the press isn't banging, if the spindle's not turning, if we're not making chips, we're not producing value. So shutting down a machine so that I can do a die changeover is actually a waste operation. As much as it's something we have to do, it is a waste operation. So sitting down and figuring out how I reduce that downtime is what SMED is all about. So, people, they're building, die holders on machines so that I can rotate the table and bring a new part under the spindle. Right, so I can actually do 2 or 3 setups and keep that machine running. Then if you have a multi-pallet, you're doing another setup on another pallet so that the next parts are ready to go the minute that preceding operation is done. Robotics, to zip dies in and out, automatic clamping. These are all part of the SMED concept. How do I keep that spindle running as much as possible? How do I keep the press making parts as much as possible? That's all about the SMED concept. Okay. Other things that we do, we talk about performance bills of material. Performance bill of material is a restructuring of your material, your bills of material, so they deliver assemblies and sub-assemblies timed to, again, their upstream requirement. So, if I've got a sub-assembly, I want its individual components to arrive exactly when it is that I have to put that assembly together, which backs into, pulls, the manufacturing of the individual components themselves. How you structure your bill of material can greatly increase the efficiencies of your manufacturing processes, may actually cause some rethinking even from an engineering perspective. Okay, Kaizens, again, there's that Japanese term. Kaizen, in another word, are quality circles or teams of individuals who get together to look at continuous improvement initiatives, identify continuous improve initiatives, and blue skying on how do we make things better. Kaizens typically meet once a week. They may spend 60 minutes, 90 minutes, and their focus is continuous improvement. Larger companies may have multiple Kaizens. They may be multiple cross-functional teams within the organization, and they get together, and this is about continuous improvement. Okay. Design for quality. Again, design for quality is understanding what quality is. Quality is more than just, the quality of the component. It's the quality of your manufacturing processes. It's the quality of your design. It's understanding the true functional requirements of your product and building in the tolerances that you need for quality, not the tolerances that you need to compensate for other vagaries in your processes. So again, we talked about tolerances of the cost difference between a 2/10 tolerance and a 2 thou tolerance. That's huge. It's absolutely huge. Do I design very complex single components, with all kinds of cross drilling and side drilling and so on? Or do I make it in 2 parts so that I can make it faster? These are all things that we think about when it's designed for quality. It's part of lean manufacturing, and has to be supported by manufacturing processes, has to be supported by flexible bills of material and indented bills of material and so on. We're going to show you in OptiPro that this is what we do, this is what we can accommodate, this is what we can assist you with. Inventory record accuracy, very popular in a lot of the webinars that we do. Can't be stressed enough. Again, it supports lean manufacturing. If you don't know what you have, how can you possibly deliver it, where you need it, when you need it, in a timely manner? To compensate for that, we build inventory. Again, inventory is just simply a bad word when it comes to lean. If it isn't sold, we shouldn't have it. And we have to have processes in place that support inventory record accuracy. So, we've talked about some of the concepts around lean manufacturing, in broad strokes. Individually, we could do a webinar on each one, burrowing down into it. Key to all of this is enabling the concepts of lean manufacturing and enabling the flexibility that allows you to get to lean manufacturing. So let's, talk a little bit about how it's done. And we're going to show you that, with some of the capabilities with our OptiProERP solution and the SAP Business One platform. So let's move that down. We've talked about bills of material, within a solution, and certainly within OptiPro, the ability to handle indented bills of material and manage the revision of those bills of material and the components within the bill of material. Clearly, if we're going to, get better and better, we're going to make changes in our bombs. We're going to make changes in our parts. From a manufacturing perspective, we have to be able to control that in an audible, manageable, visible fashion. So things like, effectivity dates. I've made a change in a sub-assembly, and therefore, I have to use up what I have, or I have to rework what I have, and I'm going to phase in the new revision. We have to be able to manage those effectivity dates. Certainly, we run into circumstances, where, we, for whatever reason, don't have what we need. Therefore, we may choose to use an alternate bill of material, maintaining the form, fit, and function, but producing it in a different way. So alternate bills of material capability gives you more flexibility. Certainly indenting the bill of material, understanding the relationship between the different components and the different sub-assemblies within the bill of material. We have to visibly be able to see that. As we drive toward lean manufacturing, something that comes up more and more, we start to move from a make-to-stock environment, i.e. I make it in a multitude of different configurations, features, and options, and I put them on the shelf and I wait to sell them. Well, hey, if you're lean and you understand the concept of lot size 1 and understand that I'm only going to produce for sales orders, well, hey, I got to have a whole lot more flexibility in what I manufacture and how I manufacture it. So configure to order becomes a new way of thinking, right? I will take my sales order and I will configure what it is that the client wants, and I will make that as fast as I can. So configuration, configure to order, flexibility, terms to understand, certainly things that, that we take care of within OptiPro. The ability to issue goods at the routing operation. Traditionally we talk about, are we going to flush, the material to our work order, where we pick everything and we issue everything out to the work order, to the assembly order, or another term we use, backflush. I will make what it is that I have to make, and when it is completed on the work order, I will backflush all the material. You can see in both of these concepts, we've got some problems. If I flush all the material and I'm making 40 pieces, I will take all of the components required for that work order or assembly, and I will push them into work in process. The minute I push them into work in process, they are not available for any other work order. Okay? I've locked them down. If I backflush the material, I will actually consume the parts, I will eat them up, I will assemble them, I can't do anything else with them, but I won't tell the system, I won't tell the inventory until such time as I completed the work order. You can see I got problems at both ends. What you really want to do is issue the materials, issue the goods at the routing step where they are consumed. So now, as close to real time, my inventories are accurate. So if I have a routing step that consumes 5, until I actually start that routing step, those 5, BOM items are actually available for something else, right? I have flexibility. Again, it's real time, it's lean. Let's talk about, quality control. The reality is what we're looking for in quality control is to move to quality assurance, right? Let's not make bad parts. Let's prevent and put processes in place so that we don't make them. So, as often as possible, I want quality assurance steps, that catch things, that identify improvement opportunities for our processes. So, you do, process reviews, quality reviews. You do them certainly at receiving, right? I certainly don't want anything bad in-house. I do them all the way through my work orders where I need them, so that where there is risk of fallout in an operation, I want to catch it there. Certainly, I can do it at the end of a work order again, so that I ensure that only good parts are getting into my finished goods inventory. And of course, I can inspect them before parts go out. And at any time, during the process, hey, things happen. So you have to have the ability to look at ad hoc inspection. The reason that you want to do inspections as often as possible through your manufacturing processes is that you can identify as close to the cause of the issue so that you understand what happened, so that you can fix the process so that the process doesn't repeat quality errors. This is how you drive process improvements to drive quality up. You have to be able to understand tolerance values. So yeah, it's fine. You can say, okay, fine. I've measured this particular dimension, but you really want a system that says, okay, fine. Here's my minimum tolerance. Here's my maximum tolerance. Put in the found value and let the system pass and fail. Okay, we can show you that in OptiPro. We have that capability. You have to have multiple inspection routines. So you can have 100% inspection, you can have sampling inspection, you can have SPC, you can have RQL, AQL, all different inspection methodologies, and we support those. Certainly, you have to be able to collect the QC data. You obviously use it for internal analysis. A lot of your customers, they want inspection sheets. So within OptiPro, we have the capability of capturing all of that data and transmitting that data. Within OptiPro, we can have a traditional walk up to a PC and do your inspection, enter your values, or more currently, more real time. We have QC on mobility, so you can actually have a tablet. So when the QA fellow goes up to do his inspection, he's actually doing it where it is that the actual inspection or the production took place. So we give them mobility, so it's real time, and again, downtime is minimized because it takes place on the spot. We handle the results out of the QC process, i.e. the fallout. So material review board is, for lack of a better word, it's an inventory location where all of these rejected items, wherever they came from in the processes, they reside within an MRB, where they then have to be disposition. So, are we going to scrap it? Are we going to rework it? Are we going to return it to the vendor? Are we going to use it as is? But an MRB location is a central location where the entire organization understands where this material is, and it can be dispositioned, and we have instant visibility at all times. All of this is supported within the OptiPro solution. Inventory record accuracy, I really can't talk about this enough. It's absolutely core. I'm sure many of you on this webinar, experience, the fallout from inventory record accuracy deficits. You go to pull something, it's not there. Why isn't it there? The whole organization mobilizes, to replace that required material. If it's out on the production floor, production has to stop. I've got to do another tear down, another setup so that the guy can work on something else. And then, somebody's got to run into purchasing, and we've got to expedite material, and there's, premium freights and all kinds of stuff going on. How do we get away from that? Well, the number one way to do it is cycle counting. Cycle count your ABC items, count them frequently. What you're really trying to do is uncover as close to the point of the discrepancy as to what happened. And again, correct the process. Did a sales guy take something? Okay, fine. We can correct that. Can he have it? Yes, he can have it, but please tell somebody. Did I have a bill of material problem, right? So the bill of material calls for one thing, but people are using something else. So, I've got too much of one thing and not enough of another. And guess what? The one that I don't have is clearly the one that I want. Cycle counting gets you to the root of that, and you can get that fixed up, get your processes fixed up so that you don't run into these, oh darn, where is it? Max min, another way of decreasing the disruptions within your inventory records. Max mins, they're not particularly, it's not a lean concept, absolutely not. However, in transition from traditional manufacturing organization to a lean organization, max mins still have their place, okay? So again, it helps the organization. Inventory counting, again, you really can't stress that enough. Reorder points, another way of ensuring that you have what you have when you need it. Again, it's a transition. It supports what you do today as you move toward lean. A lot of things that we talk about within lean manufacturing have to do with real-time information. So the batch runs, not a good thing. You want to be updating everything, on the minute as things occur. And barcoding is a way of doing that, facilitating it, making it easy. Barcoding increases the accuracy of your transactions. It eliminates, the manual interventions and digit, transpositions and data accuracy, problems and so on. And RFID is another, kind of advanced barcoding. Where instead of scanning one by one, we can actually scan, pallets of different components at the same time. But the whole idea behind barcoding is that it speeds up your transactions, makes them real time, and makes them more accurate. Forecasting. Forecasting is definitely something that you have to get really good at, and it allows you again to transition toward lean. We have some very strong tools for you within forecasting. Forecasts are traditionally based on history. Certainly we have to understand where we were to get where we have to go. And understanding the specifics of that demand is also very important. Insofar as you may have marketing programs that take place through the year. They can introduce spikes in your forecast demand. You also have to understand the life cycle of your product. You have products that are getting hot, i.e. they're trendy, people want to buy them. And then there's the older stuff. Yeah, we're still selling some of it, but they're decreasing in their life cycle. These life cycles obviously, extrapolate, into your future forecasts. You may have outliers in your demand. Big customer comes in and buys, for a particular event or a particular happening or a particular demand. They introduce spikes into your forecast. So you have to have tools that allow you, one, to identify them, and then using different algorithms, Boolean, regression, exponential smoothing, all terms that are used in forecasting to attempt to, make them more accurate as you go forward. Your forecasting tools, have to have granularity. forecast by year. Yeah, kind of interesting. Not much we can do with that. We want to get more and more granular. So, the ability to do forecasting by week, by month, by quarter, by year, all very important. And the OptiPro solution supports you in that. The other concept that you look at is consumption-based forecasting. Forecasting itself, yes, necessary tool. We need it for planning. We need it for capacity planning, as well as business planning, financial planning, and so on. But what we really need is say, okay, fine, we think we're going to do this by make and model, by time buckets, but we want our sales actually to consume that forecast. Again, ultimately you want the forecast that you're actually making in the short-term bucket to be sold items, and what we're looking out further for forecasting is merely for planning purposes. So those are your objectives within forecasting. To help manufacturing in real time, we have advanced planning and scheduling, APS. And this is finite capacity planning. So rather than infinite, which is MRP, we talk about finite capacity planning, and that's supported by our advanced planning and scheduling planner boards. It allows you to simulate production schedules, so it reflects a snapshot of real time of what your production schedule is. And it allows you to go in simulation mode and say, well, if I move these orders around, can I make things more efficient? If I get this order, what's my production plan going to look like? In OptiPro, you can run multiple simulations and save them, and then you can compare them against each other and pick the one that you want and commit that to your production schedule. We also allow you to identify, bottlenecks and overloads. You can see the top half of the planner board of the work orders as they sit on the work centers, along with the routing steps. On the top half, you can move work orders, back and forth in time. You can move routing steps back and forth in time. Those routing steps are linked in succession with all of the routing steps within the work order. So moving a routing step within a work order will cause a subsequent change within the work order itself. So if you compress a time, it will compress the finish date of the work order. And also, if you introduce a routing step or you extend a routing step, it will also push out the completion of that particular work order, and it will also show you the effect on the subsequent work order that was scheduled on that machine. A lot of complex algorithms going on here. And sitting on the lower half, you can see the green bubbles. I guess in hindsight, I should put some reds in there. But red shows you that you're within the capacity constraints that you've defined for the machine, with the shift pattern that you have defined, for the shop. As you move things around, you may cause, some of these greens to go red, which means we've got an overload situation. So the balancing, is visibly shown in our graphical planner board. So in a vacuum, you're not creating problems in a vacuum. As you move work orders around, you can instantly see, am I creating bottlenecks somewhere elsewhere or on other machines. Everything is, we show by work center, we show by resources. Another unique feature in the OptiPro product is our ability to schedule within the day. There are certainly scheduling engines out there, that allow you to look at the day, look at the week, look at the month, look at the year. But we can actually show you what's happening within the day itself. We schedule down to the minute, not by the day. Okay, powerful tool, real time. So, let's look at, we want to move toward lean. How do we measure it? Again, Peter Drucker said, if you can't measure it, you can't improve it. Hey, let's have some KPIs in place. Different levels of the organization look at measurements differently. At the executive level, consensus seems to be their number one measurement is inventory turns. It tells with a single number the efficiency of the organization as a whole. In North America, inventory turns are average around 9 times a year. Not a bad number. Certainly, it's a number that's improved. If you look at this number, 10 years ago, this number was actually like 2 or 3. So we have learned something over time. But we got to continue to drive that number up, and we can measure that in decimals, obviously, so that it becomes a relevant number at the executive level. If you want to compare yourself against people who are doing well, look at the Japanese. We keep talking about them when it comes to lean manufacturing. A lot of the terms are coming from them. We've talked about SMEDs and Kaizens and Kanbans. And I can give you a whole raft more, poke yoke and so on. Japanese average is 16, so certainly a whole lot more than us. You do have organizations like Toyota who are sitting at 26. That means they're on average moving their entire inventory at greater than twice a week. So they got something going on there, something we certainly have to do. At the executional level, day-to-day KPIs that we should be looking at, inventory record accuracy, at a baseline, 98%, it's good, but it's not great. Sounds like a nice number, but you really should be driving it north of that. Your safety stocks should be going down. If we have things under control, if you have lean manufacturing, why do we need safety stocks? Numbers should be going down. Your minimums on your stock values, again, should be heading south for exactly the same reasons. Your sales order life cycle should be decreasing, i.e. the time it takes from the time I get a sales order till I get it out the door. That number should be heading down. Work order queue time, again, that number should be heading down. If I have control of everything I'm doing out in the shop, why would I have a skid of parts sitting in front of my CNC machining center? I shouldn't have them there, right? They should arrive when they need them. Spindle time goes up, right? So I'm spending, more time, producing chips, banging parts, assembling parts, and so on. Scrap and rework is going to be going down, right? So that means we're producing less waste in our system. Our material cost of goods sold, again, should be heading down. If you take these, indicators and you measure them on a weekly basis, you very quickly see, am I going lean or am I staying traditional? Or, heaven forbid, we're heading in the wrong direction. But again, if you don't measure it, it's certainly not going to get better. Okay. So that was a little bit about lean manufacturing. And we've showed you within our OptiProERP solution with the SAP Foundation that we support that in a very progressive, very flexible manner. So let's talk a little bit about us so that you know who we are. I guess it's a sales pitch. Sorry, guys. But we have a single end-to-end solution in a modern architecture that supports lean manufacturing. Lean manufacturing is our sole focus. We don't make pills. We don't make peanut butter. I don't run governmental organizations. We do manufacturing. It's what we know. You saw my background in the beginning. I come out of manufacturing and I've spent my entire life in manufacturing. The owner of our organization is actually, a doctor. He's an engineer. It's the genetics of our organization. You can see here, all of those core things that you need in a modern solution that supports lean manufacturing. We have them. We've got the barcoding. We've got the QA, the quality assurance. We have the mobility that brings you to more and more real time, more customer responsiveness in our mobile sales application. more customer responsive in our mobile service application. Quality assurance is enabled on mobility. We've got the barcoding, we've got the inventory. Everything is real time. Real time is key to lean manufacturing, right? Batch run just simply doesn't work, from an IT process perspective. Certainly doesn't work in a manufacturing process. We're a complete solution. Critical. We're an affordable solution. We service small to mid-sized enterprise. We understand that cost is important to you. As a small business, you're growing. So certainly we have to be scalable. So whether you're 3 or 4 users or whether you're 500 users, we support both ends of the spectrum and the complexities, as they change in both those ends of the spectrum. So you have a system that you can grow with. Very secure. We're military secure in our cloud deployments and certainly on-premise secure as well. Interestingly, we have the same solution, whether you're on-premise or whether you're in the cloud. So, again, look and feel, functionality is all the same across both of those solutions. So it's important. With SAP, you got the #1 ERP solutions provider on the face of the planet. And that combine that, with our manufacturing experience, we provide a very, very reliable solution for you. We're worldwide, which is important for growing companies. Today you may have, one location, sitting in Wichita, Kansas, and hey, tomorrow you may have a European location and all of a sudden start manufacturing in China. Good to know you can be supported, around the world with a global solution. As a team, certainly we have 3 locations. Well, we're showing you 3 locations on the map here, but we offer 524 hours of support. That's standard out of the box. You don't have to pay for that. If you want 724, certainly we are able to do that as well. We're a global team of more than 400 people. And as I said, manufacturing is what we do, right? It's all we do. So, we know manufacturing and we know how to make you successful. That's what I have to say. Hopefully you saw some value in what we talked about here. Going to turn things back over to John and hey, see if we have some questions out there.
Thanks, Alan. Great job. Yes, I have 2 questions here for you. And the first one is, how do I maintain service or fulfillment levels without buffers of inventory?
Interesting question. That goes to the very core of lean manufacturing. If you understand your manufacturing processes and you have truly made yourself lean, you understand that you're pulling your systems, you're pulling all the way through your manufacturing systems. So things are arriving, at the point that they're needed, when they're needed, in the quantity that they're needed. In actual fact, you don't need inventory if you don't have to build it. And understanding that it takes me, 40 hours to make, 40 pieces, and I take 1 hour to make 1 piece, and a customer calls up and says, I need delivery in 3 days, right? Which concept is going to deliver to him in 3 days? Well, clearly, concept of 1, right? Lot size 1 is going to get him what he wants faster than if my entire production machine is stuffed with unsold goods, right? That's how you do it.
Okay, and the second one, Alan, is how do I maintain efficiency for my machines if I don't make larger run quantities?
Yeah, again, we covered that a little bit in the previous question, but this goes back to understanding what it is that I have to manufacture, and at the same time understanding the concept of SMED. Right. If I've eliminated, queue time, if I've absolutely minimized intrusions into spindle time, with SMED concepts and I don't have to wait for transit times. In actual fact, I will get the spindle time that I need on machines so that I am making value as opposed to waiting to make value. So it's the control of all of your manufacturing processes and driving out all of those components in the manufacturing process that are waste and hence not value. That's how you get there.
Okay, thanks. Don't have any other actual questions at the moment. Oh, yes, this one just came in. You mentioned Kanban, but I missed how your solution addresses Kanban of inventory.
Okay. Well, yeah, Kanban, inventory, again, we got this inventory term. Inventory, if you want to call it, in its simplest form, is really an upstream, work center, if you like, that has something sitting, waiting to be used. If you look at Kanban and what Kanban is doing, Kanban is a ticket, if you like. So I have to do a final assembly. So somebody says, well, I have to do a final assembly. Okay, well, he is going to require something for that final assembly. That something is an upstream demand, right? So he's going to Kanban a ticket to the guy upstream. The guy upstream is going to make it, and he's going to need something. He's going to ticket the guy ahead of him, and he's going to ticket the guy ahead of him, and that guy may actually need something that's in inventory. So we're pulling all the way through, and that's essentially what a Kanban is. Now, in Kanban, in its purest sense, are tickets, right? It's actually pieces of paper that's doing this pulling mechanism. If you understand, Kanban was actually first the concept itself is from 1953, if you can believe that. So it's been around a long time. Back in 1953, we didn't have ERP systems. We didn't really have even MRP back then. There was a lot of paper-based stuff going on back then. We had busy cards and so on and so on. With the advent of MRP, we got better. With the advent of ERP, and understanding, ERP with its capability of finite capacity planning, and CRP, capacity requirements planning, understanding that, we only have so much capability within our system, on each work center, on each person, and, how the calendars look. So finite capacity planning is really, if run correctly, is actually a lean manufacturing concept, because again, MRP pushes the demand forward through the system. Finite capacity planning actually pulls from your delivery date. So when we talk about backward, scheduling, backward scheduling is actually electronically Kanban, right? Because I'm saying I have to deliver this at this date. What do I need to do in order to accomplish that? And it actually takes that delivery date and backward schedules through all of the routing steps, all of the purchasing, all of the lead time to say, at each level within the bill of material, at each component within the bill of material, when do I have to start this, right? So it starts it to accomplish the finish date that's going to consume it down the line. So there's your answer there. Kanban, yes, companies are using it. In essence, do they have to? Not if they've got finite capacity planning. It's actually doing that job for you.
Okay, thanks, Alan. There aren't any more questions, and we're really out of time. So thank you, everybody, for attending today. Thank you, Alan, for a very informative presentation.
Yeah. Well, I appreciate everybody's time. The contact information there is up on the screen. I absolutely encourage you, to give me a call if you want to see something within the solution. If you have some questions on the concepts that were discussed today, more than happy to talk to you about it.
Thanks, everybody, and goodbye.